The 7-segment display is an electronic device consisting of 7 LEDs arranged in a rectangular manner. Each of the LEDs is called a segment wherein it forms part of a numerical digit to be displayed when illuminated. When two or more 7-segment displays are connected together to display numbers greater than 10, an additional eighth LED is sometimes used within the same package to indicate a decimal point. To make the 7-segment display operate, it must be linked to an IC that supports BCD inputs, such as the 7447N. The inputs will control which LEDs in the display light up. This device is widely used in different applications, such as a timer, traffic lights, calculators, etc. The students in this project will design and simulate a digital clock using the knowledge learned from CPE115L.
For the project overview, ma'am, all of the basic knowledge, fundamentals, and experiences gained from the subject and from the past laboratory experiments will be used in this project. The project objective is to apply all the concepts about digital logic gates in designing a digital logic circuit, in which we have decided into the creation of a digital clock. The digital clock that we have conceptualized is a combination mainly of ICs and a 6-piece of 7-segment display. Each time representation, the seconds, the minutes, the hours, is represented by a 2-piece 7-segment display for their corresponding double-digit numbers. And for the detailed explanation on how the circuit works and for the components used, it will be explained by my other group members.
So the components used are 6 7-segment display with decimal point common anode, 3 voltage common collector or VCC, which is the higher voltage with respect to ground, 67447N semiconductor, which is a 7-segment display decoder, 67490N semiconductor, which is a decade in binary counter, and 27432N, also known as OR gate, and two single pole double throw switch or SPDT, which is a switch that only has a single input and can connect to and switch between the two outputs. And the last is one function generator. Basically, it is a specific form of signal generator that can generate waveforms with common shapes.
So this is the digital clock circuit design. The concept of this circuit consists of data transferring from one counter to another. Each 7-segment display has a limited binary numbers to display. The counter relays the data to the 7-segment display showing a binary number n, which is 5 in this slide. After the delivered data is received, 7-segment display will show a binary number of n plus 1. So this 5 will become 6. Next. So how does the circuit of digital clock works? The function generator serves as the source of the digital clock. It is connected to the input in A of the 7490N semiconductor, which serves as the first counter of this circuit. The purpose of it is to accept the input data that it will receive. The purpose of the input in B is to generate a binary number from 0 as its first number up to 9 as its last in the 7-segment display. After the last number is displayed, it will then reset by displaying the first number, which is 0. The connection of input in B through input A of 7447 and semiconductor sends a signal information to the 7-segment display decoder, which will create a loop. Input Q of the 7490N semiconductor stores the information, which will be then delivered to the next input. Input R01 and R02 of the counter transfers the data from one counter to the other. It is also responsible for the information transfer from one 7-segment display to the other. The 7-segment display of minutes and seconds can both count up to a binary number of 60, but the condition for the 7-segment display for hours only counts up to a binary number of 24. The digital clock will reset after the last 7 segments display reach its limit, which is 24. The connection R91 and R92 of the last 74090N semiconductor is used, which will relay the information to the first counter of this circuit. So next, the digital clock project can also be set by the user's preferred time. For this to happen, an OR gate is used since there are two conditions that will adjust the 7-segment display to an output of an additional one. It can be either of these two. The first condition is that the previous 7-segment display surpassed the binary limit that it can hold, relaying the information to the next 7-segment display, which was discussed earlier. As shown in the slides, the signal refers to the transferred data of the circuit design of seconds and minutes. And the second condition is that the user can directly send a signal to the 7-segment display by means of using a source, a switch is used to connect the circuit to the line where a signal source is placed, which will relay it to the 7-segment display. The left side OR gate is connected to the switch for hours, while the right side OR gate is connected to the switch for minutes.
At the conclusion of this project, the students have already learned and utilized the concepts and basic operations of electronic gates while creating the counting circuit. In this case, a digital clock was made by the students for this application. The students use multi-sim as the platform in constructing and simulating the circuit design for the digital clock in which the outputs generated is proven to be successful. The students use a function generator for a pulse to be sent to the first counter, which it acts as a speed control for the decoder that changes the input. The counter serves as a storage for how many times the input in which the pulse waveform shifts from 0 to 1. Every 7-segment display used by the students has a corresponding counter which acts as its memory and serves as the input for the decoder. Every counter was connected to the extent that it will only count in certain levels. The segment displays are paired to show a 2-digit time in hours on the leftmost part, minute in the middle, and seconds to the rightmost part of the circuit. To summarize, this digital clock circuit has various practical applications and are still widely used even today.